From the Medical University of South Carolina, this is Science Never Sleeps, a show that explores the science, the people, and the stories behind the scenes of biomedical research happening at MUSC. I'm Gwen Bushy. As we age, our brains undergo changes that can lead to a range of cognitive issues, impacting memory, decision-making, and overall mental sharpness. With life expectancy on the rise, the implications of cognitive decline extend beyond the individual. The societal and economic consequences are vast, making the pursuit of effective interventions and preventive strategies more critical than ever. According to the 2022 Census, someone in the U.S. develops Alzheimer's disease every 65 seconds, and by mid-century, it will be every 33 seconds. But what exactly causes this decline, and why is it so crucial for us to understand? How can early detection improve care for patients with cognitive impairment? Our guest today is Dr. Stephanie Aghamoosa. Dr. Aghamoosa is an assistant professor in the Department of Health Sciences Research in the MUSC College of Health Professions. Her work focuses on improving the early detection of cognitive decline in Alzheimer's disease. Her science underscores the importance of ongoing research in preserving and optimizing cognitive function, ensuring a brighter and more cognitively resilient future for us all. Stay with us. Dr. Aghamoosa, welcome to Science Never Sleeps.
Thank you for having me.
So when we think about the aging brain, what are some of the changes that tend to occur? What are we talking about when we think about cognitive decline in the aging brain?
Yeah, changes that happen to the brain as we get older are really multifaceted. There are lots of different causes and lots of different ways that our brains change. When we're talking about just typical aging, so people just getting older, not necessarily with the presence of disease, we do have cell death. So the cells of the brain die off and we get what's called atrophy, so shrinking of the brain just generally. Because of this cell death, there's also less efficient communication between brain cells called neurons. And we tend to see less blood flow to the brain as well as we get older. And so all of these sort of typical aging changes to the brain can make it so that our brains process information more slowly, less efficiently. It can be harder, for example, to come up with names or with the word that you're thinking of. You get that tip of the tongue sort of experience. It can cause some trouble paying attention and can also cause some minor memory slips. So the sort of I misplaced my keys sort of memory slip. Right. All of that is part of what we call typical aging and something that everyone experiences as they get older. And that is separate from changes in the brain that happen as a result of disease. As you know, is well known, Alzheimer's disease is the most common cause of more accelerated, more severe changes in the brain, which that is a biological disease that causes more cell death, more atrophy, and more disruption of all of those processes that I just mentioned, right. With one of the most prominent being memory impairment. Right. So difficulty making and storing and recalling memories.
Right. So then the aging brain is something that we all have to deal with.
Yes.
It happens. And when we talk about the disease or disorders, that's something different.
Yes. With that being said, those diseases are becoming more and more common. So, estimates suggest that 1 in 9 or 10 individuals over the age of 65 are going to experience something like Alzheimer's disease and develop something like dementia at some point. And with our older population growing, the baby boomers, growing into older age, the numbers of people that are going to experience cognitive impairment. So again, much more severe changes in their thinking abilities than is typical. Those numbers are going to continue to get larger and larger.
So what brought you to this area of research of the aging brain? What was it that drew you here? What is your science story?
Yeah. So I am the daughter of two psychologists. So call it nature or nurture. But I've always been really interested in the brain. In college, I took a neuroscience course and I was just enthralled by the brain. And at the same time, I had a lot of experiences, both in my personal life and through service that I was involved in, where I was seeing older individuals coping with cognitive changes. And it got me really motivated to pursue a career really with the passion of prolonging cognitive, emotional, functional health into aging. I can't pinpoint one exact experience, but I've just always sort of known that I wanted to do science that helped promote brain health.
Right. And to do that science here in South Carolina is particularly poignant because we know that as the census is showing that by 2030, South Carolina will be the home to 1.4 million people ages 65 and older. And with, as you said, what was the stat again about folks over a certain age?
Yeah, so it's 1 in 9 or 10 people over 65 will develop something like Alzheimer's disease.
Right. So we have this big implication in the state of this growing population, which means we're going to have a growing amount of people who are experiencing these type of disorders and disease. And there is a tremendous cost associated with the care for someone with dementia, both in a monetary form, but also in a societal form in terms of the toll it takes on families and caregivers and those types of things. So it really is more critical now than ever to be focusing on this research, right?
Absolutely. And something that I think makes it even more critical, and the data are there to support it, is that South Carolina, the southeast region of the United States that includes us in South Carolina, is actually a region that shows even higher rates and risk of Alzheimer's disease than other areas of the country. One of the potential driving factors with that is that our area of the United States is considered part of the stroke belt, meaning that we have higher rates of people with cerebrovascular disease that can lead to stroke. What has become clear in the Alzheimer's field is actually that Alzheimer's disease and vascular contributions, so problems with your vascular system that can lead to stroke, have an interaction effect that worsen your risk of Alzheimer's disease. And so I think part of what is driving those rates is that increased rate of vascular issues in our area of the country. But what that translates to is that we have even higher rates and risk of Alzheimer's disease than is present in the country, which in the country generally it's considered a very important issue.
Right.
So I think, the people of our state are going to be disproportionately affected, which makes the research that we're trying to do even, I think, more important.
Right. So are there any particular groups that are impacted by this issue more than others? We all have aging brains, but are there some groups that might be impacted more than others?
Yeah, there definitely are. It's become really clear in the literature and in large studies of Alzheimer's disease and other related dementias that people of color, so people who are part of minoritized, underrepresented racial and ethnic groups, tend to have higher rates of Alzheimer's disease and development of dementia. As we've talked about, there are health conditions that increase your risk of Alzheimer's disease that aren't Alzheimer's disease itself. So things like vascular disease. So if you've had heart disease, if you've had a stroke, or if you have risk factors for those conditions, that increases your risk of developing Alzheimer's disease, and you will develop it sooner. And in these groups, these underrepresented racial and ethnic minorities, people of color, we see higher rates of both things. And so it's a compounding effect where there are higher rates of medical conditions that also increase your risk for Alzheimer's disease. And then when you get into groups that have poor access to healthcare, having less access to healthcare earlier in the disease course is going to worsen the prognosis, the progression. And so it's a big, complicated mix of social factors, environmental factors, and medical factors that are disproportionately affecting certain groups of people.
And what about, do we see it gender-wise? Are there any differences there in terms of how it presents in gender?
Yes. So women are actually at a higher risk of faster cognitive decline and higher rates of Alzheimer's disease. The biological reason for why this is not clear. No one knows. But the effect is definitely there. And women, there is some suggestion that potentially changes with hormones, perimenopause, postmenopausal hormones, could play a role. But again, that link is not yet extremely clear. But what we do know is that women are at a higher risk of developing Alzheimer's disease than men.
And we would say questions like these are why it's so important that research continues, right?
Absolutely.
To answer these fundamental questions that we have.
Yeah.
So speaking of research, you are a researcher, obviously. That's why you're here.
Yes.
So tell us a little bit about your specific line of investigation around this particular area.
Yeah. So my research really had its roots in healthy aging. I was really interested in, as a graduate student, helping with studies that looked at behavioral interventions for promoting brain health in older adults. So that was things like mindfulness meditation, physical activity, cognitive training, all of these ways that we might help promote and prolong cognitive longevity. My interests then began to morph into, okay, we do know that some people age typically, but a lot of people are experiencing cognitive impairments, particularly due to Alzheimer's disease. And so I shifted my focus and my specialty to the early stages of Alzheimer's disease. And so my research currently, I would say, has two very related focuses. One is to better understand the early signs of Alzheimer's disease from a brain and cognitive perspective. So I use brain imaging, I use cognitive tests to try and detect what we call preclinical Alzheimer's disease before people have symptoms. The second focus of my work is actually to develop interventions, so non-drug treatments, that can be applied in these early disease stages. So when people don't yet have symptoms or maybe have mild symptoms, a condition called mild cognitive impairment or MCI. What sorts of interventions can we do during these stages to hopefully slow progression, prolong independence, keep people in their homes, in their communities, doing what they love to do. And so those two aspects, I think, for me, marry very well together because they inform each other. And those are the two areas that I'm focusing my work.
Are there also lifestyle factors that come into play when we think about Alzheimer's disease and related disorders?
Absolutely. So much research in this area has been done and has identified actually quite a few things that people can do that reduces the risk of developing Alzheimer's disease. And conversely, things that people do that increases their risk of the disease. And so there are a couple different sort of aspects or domains of life that are the heavy hitters here. One is physical activity. So we know that people who are very sedentary, who don't get as much activity, have a higher risk of Alzheimer's disease. And on the flip side, when we intervene, when we have people exercise in a research study, we actually see their brain health improve and their cognition improve. And so there are very strong recommendations that people should try to stay physically active as much as they can throughout their lifespan.
Mm-hmm.
So starting, when you're young, thinking ahead and making physical activity a part of your daily life is going to reduce your risk.
So we add physical activity. I mean, it just seems like it's so good for so many things,
It
whether
is.
it's body or brain.
It
or,
is. And
yeah,
I do love
yeah.
to say when I have seen patients in clinic, what is good for your heart is good for your brain.
Mm-hmm.
And I think that's a good way to think about a lot of these lifestyle things. So physical activity, absolutely. Another one is staying cognitively active, and that can look a lot of different ways. Some people immediately jump to, should I be playing crossword? Should I be playing brain games? But actually what has the biggest bang for your buck is more complex activities that you probably do on a day-to-day basis that you don't think about but are actually cognitively demanding. So things like socializing in a group, having complex conversations about the news, about a book you read, those sorts of interactions are actually very cognitively stimulating. And you get that social piece as well, which is a piece of the puzzle. Staying socially connected, not being lonely, is actually going to reduce your risk of developing cognitive impairment. Third is nutrition and sort of your physical health more generally. So it's recommended that you eat a diet that is high in fruits and vegetables and low in processed foods generally. There's not one specific diet that is going to reduce your risk, but just keeping those general healthy eating tenets in mind is going to reduce your risk. Related to that is managing medical conditions. So we've talked a lot about how heart disease and risk for stroke, high blood pressure, high blood lipids, all of those things are going to increase your risk of dementia. And so working with your medical providers and with these lifestyle factors to manage those is an extremely important piece of the puzzle. Mm-hmm. A couple others I want to mention are not smoking. Smoking increases your risk of developing Alzheimer's disease and dementia. Avoiding heavy drinking. Making sure you're getting really good sleep to the best of your ability. I know we all sort of struggle to get that 8 hours, and it doesn't have to be 8 on the dot, but getting quality sleep and addressing any sleep issues. So if you're experiencing insomnia or if you have sleep apnea, those things add up over time. And so having, for the most part, as solid sleep as you can is going to reduce your risk of Alzheimer's disease and dementia. And so I think I've hit a lot of the big ones. There's quite a few and it can feel overwhelming, but I always tell people, choose the one that resonates the most for you, that sounds like, oh, I would like to see that change in my life, or I've been thinking about making that change. Maybe now's the time to do it, and start there. And then build. These are habits. And so, slowly making these changes in a sustainable way to your life, over time, that adds up and reduces your risk of dementia.
And maybe give yourself credit for the things you're already doing, too.
Absolutely.
To encourage the changes that you might want to make.
Absolutely. That's such an important part of, you sound like a psychologist, such an important part of any sort of behavior change is introspecting, looking at where am I already doing these things and where are some spots, 1 or 2 spots to start where I could make improvements, and bring along those around you. We know that we're more likely to make and sustain a change in our life if we have the people in our lives on board with us. So bring them along, make the change together, hold each other accountable. And again, small steps and in moderation, right? So it's not that I need to exercise every day of my life, but on the aggregate, on a weekly basis, am I getting close to that 150 minutes of activity that is suggested? I think for most of us, there's some room to improve there. And so I think the great news is that there's a lot of room for incorporating these things in your life to reduce your risk.
So you mentioned that one of the first angles of your research is in this idea of how do we detect these cognitive declines earlier. So can you tell us a little bit about why this is so important? And my guess is it ties into your second line of research.
Yes,
But can you talk about
yes.
that a little bit?
Of course. You're absolutely right. So the whole idea behind early detection, and I should say this is not a novel idea of mine, this is a huge priority in the field. And the reason is because there is no cure for Alzheimer's disease currently, medically. If our goal is then to just slow the progression, push back in time when someone might develop symptoms, we're going to be able to do that best by intervening early. If we can give someone a treatment, a lifestyle modification, a medication, whatever it might be, if we can do that early before symptoms present themselves, the thought is we will be able to more effectively prevent it from worsening or slow the progression. And so for me, the importance is, one, to understand scientifically what's happening. So it's kind of a science question rather than an application necessarily. But the second part to that is that translational piece. It's if we can understand the cognitive and brain changes that happen early, if we can find those individuals and know that they are at risk of developing this condition, then we can target our interventions there. We do have a very good understanding of the early clinical syndrome. So that's that mild cognitive impairment, MCI, that I'm talking about. So that's when people start to experience the initial cognitive impairments and behavioral changes that occur early in the disease, but they're still functionally independent. They can still live their daily lives, do the things they want to do. That's MCI. And we have that well characterized. People are diagnosed with that currently, and that actually is where we're targeting our interventions right now. But I think the idea, the sort of ideal situation would be being able to find and intervene even earlier before people are appearing in clinic with symptoms.
Right. And so one of the interventions that you have been looking at is transcranial magnetic stimulation.
Yes.
So can you tell us what that is and what does it mean for intervening in mild cognitive impairment?
Yeah, so transcranial magnetic stimulation, or TMS, it's a bit of a mouthful, is a way of non-invasively and painlessly stimulating the brain. What I mean by that is we simply hold a magnetic coil, so a big magnet, against your head, just next to your head, and that coil delivers magnetic pulses through your skull, through into your brain. And what that does is it activates or stimulates the part of the brain that you're holding the magnet over. And again, it's painless and can be done. Someone can walk in, have it done, and walk right out. It's actually an FDA-approved treatment for depression and other mental health conditions. What we are doing is we're taking that modality, that treatment, TMS, and trying to use it in people with mild cognitive impairment to see if we stimulate areas of the brain that are important for the types of thinking difficulties that people with MCI experience. Can that help, improve their cognition? We're in the very early stages of doing that, but we've actually completed an initial study of 22 people who received this treatment and showed that it was perfectly safe, highly tolerable and acceptable. People actually liked it, and that we do have some preliminary evidence that it might improve cognitive function, thinking abilities. And so this is really exciting because, again, this is a non-drug way, could certainly be used in combination with drugs if there was a medication that the person was on. But it's another way that we might be able to intervene and improve cognition.
So tell us a little bit about what it looked like. So you said you just wrapped this first phase of the study, and I know you've also started a new phase, which which we'll talk about in a second. But what, for the participants who were in that study, what did that look like for them? What did participation look like? Because I think sometimes we don't really talk about what does it look like for folks to participate in research, and it's really important because we want people to understand and know that those options are out there, and that participating in research is important. So can you talk a little bit about what the experience was like for participants?
Yeah, absolutely. So these participants all had a clinical diagnosis of mild cognitive impairment from a provider. That was a requirement for the study. So these people with MCI, they enrolled in the study, and they had 5 visits that they completed. So 2 of those visits were assessments. So we wanted to measure their cognitive function, their mood, a bunch of other characteristics right before and right after treatment. The 3 other visits were the treatment visits. So on 3 days, within about a week span, they could choose whichever day they wanted. They came into our lab and received treatment for about 2 hours. And what treatment entailed was the transcranial magnetic stimulation, TMS. And the TMS, the way that is delivered is actually in bouts of 3 minutes at a time. So it's not that you're getting the treatment for the full 2 hours. So you would sit in a big, comfortable chair. It sort of looks like a dentist chair, sort of reclined. We would place the magnet next to your head, and you would receive brain stimulation for about 3 minutes, and then you would get a break. And then we would do that again. And there were 8 of those sessions on each day. So again, about 2 hours in the laboratory. And people could take breaks when they needed to, if they needed to get up out of the chair. And many people found it very relaxing to sit and get this treatment. Some people, in full disclosure, do experience some tingling, a tapping sensation on their head, various sort of mild sensations. But that's also something that we could modify the way the treatment was being given to make sure they were comfortable. And so 3 treatment days of that, and then that assessment that I mentioned to look at cognition and brain function afterwards. And that was the extent of participation and the treatment. I will say this form of TMS that we are giving, the reason it's able to be given in just 3 days is actually because it's a relatively newer form of TMS called accelerated theta burst stimulation. And this actually takes what used to be a treatment that was daily for 4 to 6 weeks and can deliver it in just 3 days. So that was a big innovation, is a big innovation of this line of work that we're doing. And we did ask participants how they felt about being able to get this in 3 days versus multiple weeks daily. And they, by and large, as you can expect, prefer this shortened, condensed version.
Right. Yeah, because who wants to?
Right.
I mean, it's a long commitment, right?
It would have been a very long commitment, and for individuals with MCI, who are older, sometimes tolerating a very lengthy treatment is not in the cards, or logistically not feasible. So this, I think, really opens up the door, if this treatment is found to be very effective, opens up the door for a really viable treatment option, which is what we hope.
Right. And so this study, you sort of got to see that it's tolerable. People can do it. There's, some potential there.
Yes.
So talk about this next phase that you guys have started.
So we were very excited. Yes. So in the first study, we showed that it was safe, which we completely expected it to be, but demonstrated that tolerable, acceptable, and looked at the preliminary effects. We actually then used those findings to put in a grant application to the National Institute on Aging to conduct a dose finding study. And so in this now current study that we're running, the goal is to figure out how much TMS do we need to give to improve cognition and to improve depression. So something that we haven't mentioned is that people with MCI and people with Alzheimer's disease actually experience mood problems at a pretty high rate. So things like depression, anxiety, insomnia. And so in this next study that we're running now, people have to have MCI and some depression. Mm-hmm. And so we are trying to figure out, because it's not known, how much TMS is enough to improve symptoms for people. Mm-hmm. So we're really excited to take this next step because once we know the right dose, then we can move on to really large studies that can really tell us how effective is this? Does this treatment really have a potential to, come into clinics to help people with MCI?
So what is next for you in your line of research, or that you think might be some of the next big questions for research in this space?
Yeah, so something I'm really passionate and excited about that I'm pursuing is using TMS as an adjunct for other interventions that already exist that we know can help improve cognition in older adults and people with MCI. And so what I mean by that is things like cognitive training. So one of the studies that I'm planning is actually combining the TMS treatment that I described to you with an evidence-based cognitive training program. The idea being that TMS stimulates the brain, primes it, gets it ready for people to then practice cognitive skills that are maybe lacking for them. What I hope and what I'm going to test is whether doing that combination actually helps those cognitive skills stick so that they are improved and you see lasting improvement by combining these two interventions. I think the implications of that are, we've talked a lot about lifestyle factors and risk for Alzheimer's disease, and one of those things is cognitively stimulating activities. Well, if we can sort of package that with this brain stimulation modality, maybe we can boost the protective effects of that. So that's an area that I am actively pursuing and hope to run a study testing that very soon.
So is TMS actually changing the brain at all, or what are we seeing when we utilize that mode of treatment?
Yeah, it definitely is. There, I think, are still some open questions about exactly how, but the way that people think about the effect of TMS on the brain is you send a magnetic pulse, into the brain region. It stimulates it, but what it is doing is it induces neuroplasticity. And what that word means is it causes the brain to be more plastic, more malleable, more changeable, able to learn, able to change the way it's processing information. So it's kind of an abstract term, and there are some biological ways of looking at neuroplasticity. For example, if you see cell growth, or if you see changes in the connections of the different brain regions, all of those things are used to indicate neuroplasticity, but that is kind of the presumed mechanism. That's the way that TMS changes brain function, is it makes it more plastic.
So this new research question really is asking how do when you combine two things that could impact neuroplasticity that we talked about earlier, that you combine these two things together and you really could possibly, the question is, can you boost how much of that brain change is happening?
Yes. So the way that I think about it is we know that TMS induces neuroplasticity. It opens what we call a window of neuroplasticity that lasts actually for some time after you do the stimulation. And so my idea is that if you give someone TMS, open the window of neuroplasticity, and then engage their brain in cognitive training, meaning they're practicing cognitive skills, that might actually capitalize on that neuroplasticity. The brain might be better able to learn those new skills, get better at those skills, and that will boost the effects more so than either alone.
Dr. Aghamoosa, it has been a pleasure to have you on Science Never Sleeps.
Thank you so much for having me.
We've been talking to Dr. Stephanie Aghamoosa about her research on the aging brain and cognitive function. Have an idea for a future episode of Science Never Sleeps? Click on the link in the show notes to share with us. Science Never Sleeps is produced by the Office of the Vice President for Research at the Medical University of South Carolina. Special thanks to the Office of Instructional Technology for support on this episode.